Good afternoon, everyone. So, in the last class, we were talking about different types of peer to peer networks. We had discussed Napster, we had discussed GNutella, and we had discussed Katsa network. Now, today we'll discuss about a very popular peer to peer network, which is BitTorrent. So, the problem with the previously studied peer-to-peer networks was that they implemented some form of client-server architecture in the peer-to-peer network. Like in Napster, we saw that even though the downloading was peer-to-peer, yet to publish your data, you had to contact the server. Even in Kazaa, you had some super nodes which would like serve as a server for other peers in the subset of the network. So the problems that BitTorrent tried to address were twofold. First, it tried to address the traditional client server sharing system. That is, in a client server system, the performance will deteriorate if the number of clients in the network increases. So when we are talking about a peer-to-peer network, which is a very huge network, and we have millions of nodes, so we can't be dependent on servers for providing us with data or services. Second problem, which exists in like the most common problem that exists in any peer-to-peer network, is the problem of free riding. It is not actually a problem, it is kind of a phenomenon. So what happens in free riding is that peer consume resources of the network, but they do not contribute anything in return. So they are only downloading files from the network, but since uploading requires you to like spend your bandwidth, so what some peers do is that they will only use the peer-to-peer network for downloading the files that they need, but they would never use their bandwidth to upload anything to the network. So they're only downloading without contributing anything to the network. So now peer-to-peer, now BitTorrent is one of the pioneering applications in the peer-to-peer network, and it is to this day a very popular application. Now it has very interesting features which we shall see in the course of this lecture. Now whatever we have studied about peer-to-peer networks, like we have studied three peer-to-peer networks, and all of those peer-to-peer networks focus on efficient search. That is, their focus is on utilizing the network in such a manner that whenever a peer is searching for some file in the network, he is able to uh, find that file in an efficient manner. So most of the peer-to-peers focus on efficient search. But BitTorrent network, it ignores this idea. It does not focus, like keeps it focus on efficient searching, but goes in a completely opposite direction. So the focus of a BitTorrent network is not on efficient search, the focus is on efficient fetch. So we know that with respect to any peer-to-peer system, there are four operations that we perform. We join the network, we publish something onto the network, we search something on the network, and we fetch or download something from the network. So almost all of the peer-to-peer networks focus on efficient search, but BitTorrent focuses on efficient fetch. So why does it do this? Now, in the file sharing community, what is often seen is there is a huge amount of flash crowd. So what is this flash crowd? So we are saying is that in a peer-to-peer network or in a very large file sharing community, there is often a huge amount of flash crowd. So let us see this with the help of an example. So suppose, let us assume that a new game releases. So a new game is released and a lot of people are interested in downloading that game. So if we were to plot the graph of popularity, so if we try to plot a graph of popularity, that is, here we have the time, and we would see that, sorry, just a second. So if we are going to plot a graph of popularity, here we would have number of users against time. So if a new game releases and when a game is released, the popularity of that game would shoot up and gradually it would come down. So the popularity shoots up whenever some new game is released, but gradually the popularity declines. So again, if some movie is released, then again the popularity would shoot up again and then it would come down. So these crowds downloading games or movies are called flash crowds. That is, at a given point in time, there are tons of users. Now, at any given point of time, there are like tons of users who want to download this file. So if you're going to like see how many users are there at any given point of time, the number of users is very high. So what we're saying here is that there are certain crowds who would come to these platforms to download the games, to download the movies, and these crowds, these groups, these users are called flash crowds. So there are points where users want to download a particular file, that is, and thereby it is important to ensure that all users are able to download these files. So what we're saying here is that we know that in a peer-to-peer network, the nodes enter the network, the nodes leave the network at their will. That is, we have a transient population of nodes. Also, when some new game or some new movie releases, then we see a huge crowd of users who want to download that file, who want to use that, like download that movie. So the pressure or the traffic on that peer-to-peer net file sharing community increases. So it is important to ensure that all users are able to download these files. So what used to happen in the past was that when a company was releasing a game, they would have a single source which would provide the game and a set of mirror sources that would facilitate the downloading of the game. But as we know how client and server systems are, these kinds of systems, like, they brought a very high cost to the company, and the servers also became bottlenecks. The server will become bottleneck when the client population is very large. So with the help of a peer-to-peer network, we can leverage the resources that are provided by the peers. The resources they could be providing files, they could be providing workspace, they could be providing some processing power, so any kind of resource. So here what we're saying is, with the help of a peer-to-peer network, we can leverage on the resources that are provided by the peers. So BitTorrent is a peer-to-peer system which forms a swarm of peers. So swarm of peers means we have a group of peers, and all these peers are interested in the same file. So BitTorrent will form a swarm of peers, and all these peers will be interested in downloading or uploading the same file, and within that swarm they would like ensure that the file is downloaded efficiently. So in other words, within a swarm, each user can upload or download files from other peers simultaneously. And we're using the term swarm in the sense that these peers who are forming the swarm will only be like interested in the same file. So let us see how this is happening. So imagine you have a very large file and you want to share this file with other peers on the network. So we are saying that you have a very large file. So this is your file. Suppose your name is peer A, and you want to share this file with others on the network. This could be peer B, this could be peer C, this is peer D, and so on. And this is, suppose this is peer E. So we are saying that imagine you have a very large file that you want to share with other peers on the network. And here we can see that we have a set of users, a set of peers who are interested in that file. So since these users are interested in that file, that is, these users want to download this file, so these set of users will form a peer. Sorry, these set of users will form a swarm. So what happens in a BitTorrent network is that you divide the file into chunks. So suppose this is a very big file. So what we'll do is we will divide this file into chunks. So this is one portion of the file. Suppose this is another portion of the file. This is another portion of the file. So different colors will denote different portions. Okay. So what we have done here is we have divided this file into different chunks or different pieces. So in the beginning, what is happening is only peer A will have this file. The peer A here has the complete file. Slowly what it will do is it will start passing these chunks to other peers on the network. So what will happen is, suppose this peer transfers a chunk of this file to E. That is, this portion of file has been transferred to E. And it transfers this portion of the file to B. So now what will happen here is, we are saying that peer A has divided this file into chunks and it is sharing this file with peers. So after some time, what will happen is this peer E now will have this segment and this peer B has this chunk. So now since peer E has this first chunk and peer B has this second chunk, what will happen is that they have the liberty to share this chunk with other peers on the network. So peer E can send this chunk to peer peer D, and peer B can send this red chunk to peer C. So we are saying that chunk to peer C. So we will have a chunk here, and peer E can send this blue chunk to. Now suppose our peer A shares this chunk with this and also with this. So it will have this file and it will have this third chunk. And similarly, peer E, now since it has received this third chunk, can share with peer D. And peer B has also received this third chunk. So it can also share this third chunk with peer C. So after some time, all of these peers will have all of these chunks. So we are saying is that after some time, all of these peers will have all of these chunks. So slowly what we are saying is the peer, which is peer A in our case, will slowly start passing these chunks to other peers, and these other peers are also establishing connections with all other peers, and they're pushing these chunks among themselves. So after some time, all of these peers will have the complete file. Initially, only peer A had the file. After some time, all the peers like peer E, peer B, C, D, all of them will have the complete file. So whenever some peer receives a chunk, he can share it with other peers he is connected to. So in this way, after some point in time, all the peers will have the complete file. That is, peers continuously keep establishing connections between themselves to push these chunks in order to get the complete file. So this is an overview of how uploads happen. Now there are two issues, two challenges associated with this. First is churn. Now we know that in a peer-to-peer network, a node is not permanent. That is, at any given point in time, a node can go off. That is, it will no longer be available on the network. Any of these nodes, suppose this node can go down, this node can go down, any node can go down. Second challenge is freeloading. Freeloading or free riding. So in freeloading, we know that we have already discussed that we have peers who are only using the network for downloading some information, but they are not uploading anything to the network. And if everyone is a freeloader, that is, everyone is only going to download and not going to upload anything on the network, the system is not going to function properly. So the two challenges are that the nodes come and go, and the second challenge is that there may be some nodes or there may be some peers on the network who are only using the network for downloading, but they're not uploading anything on the network. So this is the overview of the peer-to-peer network. So let us now see how join, publish, search, fetch, all of these operations happen with respect to BitTorrent network. So we will discuss the four basic operations with respect to a peer-to-peer network. With respect to any peer-to-peer network, like all of these operations are common to every peer-to-peer network. So we will discuss about the four basic operations, that is join, publish, search, and fetch. Now here we will go in a different order. We will not see how join happens. First we will see how publish happens, and the reasons will become clear to you shortly. So let us first see how publish happens in a peer-to-peer network. So by publish, we mean that you are telling the network that you have something that you wish to share. And publish is kind of, you can think of publishing in terms of uploading something to the network. So let us see in a BitTorrent network, how does one publish the file that they want to share? So in order to share a file or in order to share any media file on a BitTorrent network, you will first have to create a torrent file. That is, you will first have to create a torrent file which contains two pieces of information. The first is metadata about the file, that is name of the file. And as like I mentioned previously, that a file is divided into pieces. So what we'll do here is that when you divide a file into pieces, for each of these pieces, we will compute the hash. And the piece size is also mentioned in the metadata. So what happens is, when you want to publish anything on the network, you will have to create a torrent file. So torrent files come with a .torrent extension, and in that torrent file, you will mention certain data. So what is the data? You'll like provide information regarding the metadata of the file, that is the what is the name of the file, how many pieces you have divided the file into, and then you will mention the hash of each piece. You will also mention the piece size. Typically a piece size is 156 KB in length, and you also need to include the URL of the tracker. So what is a tracker? We'll see. So here we have a file. We have divided the file into different pieces, and each piece is divided in further divided into sub pieces. So typically in a BitTorrent, when you divide a file into piece, each piece can be further divided into only 16 pieces. So this is the limit for any sub piece. And the piece size here is 256 KB. So we are saying that you provide two information. One is the metadata about the file, and second is the URL or the IP address of the tracker. So first is the critical, let us see the critical elements. We have the .torrent file, that is you provide a torrent file which has a .torrent extension. It will have some metadata information, that is the name of the file. You will provide the size, you will provide the hash of the file, then you will provide the IP address or the URL of the tracker, and then you will provide the piece length. Piece length is the size of each chunk, that is the number of chunks you have divided the file into and the size of each chunk. And typically what happens is, when you divide a file into pieces, typically it is 256 KB in length, in byte, sorry. So the first critical element is the torrent file. Second, what happens is, we'll talk about the BitTorrent tracker. So a tracker is a server that is going to coordinate the file transfer in a swarm. Now, in a swarm, we will have a group of peers who are associated with uploading or downloading a single file. So there will be a tracker that is going to coordinate the transfer of files in the swarm. That is, it will keep track of all the peers that are present in the swarm. That is, it has a list of all the peers that are present in the swarm, and the tracker is going to help any peer who is part of that swarm. So now these tracker servers can either be public type or they are private. So a public tracker is a tracker that anyone can use them. But if you have a private tracker, you can only use their services by invitation. That is, you need to be invited in order to use a private tracker. So you have created a torrent file. Now what you do is, once you have created a torrent file, you put this file up on the web server. So again, there are some web servers that provide the service of like they will provide you with a list of all the torrents that are out there. So you can publish your torrent file on such a web server. So this makes the task of searching easy. So once you create a torrent file, you can put this torrent file up on a web server, and we have a wide variety of web servers whose only task is to provide other peers with the list of torrents that are out there. So this will make the task of searching a torrent file easy, and we will see this shortly. So you have created a torrent file, you have uploaded this torrent file on a web server. Now you also need to ensure that there is a machine on your swarm that has the entire file. So when we were discussing about the overview of the BitTorrent network, so we initially had a peer who had the complete file. Here also, you need to ensure that when you are joining a swarm, there should be a peer on that swarm who has the entire file, because you will need someone within the swarm that has the entire file. So you need to ensure that there is an initial seed. So what is a seed? So in BitTorrent terminology, a seed is a node or a peer who has the complete file. Now, let us see how search or joining operation happens on a BitTorrent network. Now, one important thing to understand here is that in BitTorrent, searching is out of band. Out of band meaning that there is no facility, that the BitTorrent software does not provide facility for you to search a file. You cannot search torrent files on a BitTorrent software. You will have to use Google, or as we mentioned that there are some very popular websites that host torrent files. That is, we have web servers, some very popular websites that would host the torrent files. So on those websites, you can type the keywords to get the torrent. So you will have to make use of these websites or these web servers to get hold of a torrent file. So suppose this is a peer. Now this leech, we'll see what a leech is. But for now, let us assume that we have a peer A who wants to download some file on the BitTorrent network. So what will this peer will have to do first is it will have to get hold of a .torrent extension file for that, whatever file it wants to download. So once the user gets hold of a torrent file, now here we can see this peer A has received a .torrent file. So once it gets a .torrent file, he or she will have to join a swarm based on the torrent file. Now how will this peer A identify which swarm to join? So as mentioned previously, in a torrent file, you also mention the URL of the tracker. You provide the metadata information and you provide the URL of the tracker. So when a peer wants to join a swarm, he will have to contact the tracker which is listed in his torrent file. So now here, peer A has received a .torrent file. This .torrent file contains the metadata information about the file, and it also includes the URL of the tracker. So now what this peer A would do is, it will contact the tracker server. So peer A contacts the tracker which is listed in her or his torrent file. And as part of your contract, you as a peer will provide your IP address and port information to the tracker. So the amount of upload or the amount of download does not matter when you join the swarm. But later, when you are part of the swarm and you upload and download data, you will have to periodically inform the tracker about your uploads and the downloads. So this is why, as part of the contract, that you provide your IP address and the port information to the tracker. So when you announce yourself to the tracker is going to tell you that, see, these are the other peers who are also downloading the same file. So the tracker will provide you with a response peer list. That is, it will provide you a peer list as a response that, okay, you requested, you want to download this, suppose xyz.torrent file, and in that torrent file you have the name of the tracker. This peer A contacts the tracker, announces itself to the tracker, and the tracker in response provides the peer A with a peer list saying that whatever file you are wanting to download, there are also other peers on the network who are downloading the same file. So it provides peer A with a peer list. So now this peer A can, when it has the peer list, it can directly contact this peer C and this peer B. Now we have said that whenever you form a swarm, you have to ensure that there is one peer on your swarm that has the complete file. That is, who is the seeder. So in our case, this peer C is a seeder. Seeder in the sense that it is a node which has the complete file. So there is handshaking between them, and after this handshaking, they can transfer pieces to one another. So this is how searching or joining a swarm happens. Now, let us see some terminologies. So also, like if you are A establishes a connection with peer C, it also establishes a connection with peer B. Peer C transfers some pieces to, like peer B transfers some pieces to A. Peer C will transfer some pieces to A. And in return, A can also transfer some pieces to B. Because since C is the seeder, she has all the pieces. But B is not the seeder. It may happen that it has some chunks of that file, but it may not have the complete file. So here A can also help B by providing it with the pieces. So this is the overlord or architecture. You get a torrent from the web server, you announce yourself to the tracker. How you announce yourself to the tracker? Because the IP address of the tracker is present on the torrent file. And from the tracker, you get a response list, that is a peer list. Then you can directly contact the peers for getting the file. Also, you need to ensure that when you are establishing a peer-to-peer swarm, there is one peer in your swarm that is the seeder, that is, who has the complete file. Now, let us see some terminologies with respect to this BitTorrent network. Now, BitTorrent makes use of certain terminologies, and let us get familiarized with those terminologies before we can proceed any further. So seed is a node which has the complete file. So whenever you join a swarm, there is definitely one initial seeder, but as other people download the file, they can also become seeds. So when you're joining, it may happen that in your swarm, there is only one seeder. But as the transfer of chunk happens between different nodes in the swarm, other people who have downloaded the complete file can also become the seeds. Then we have a leecher. So leecher is a node that is downloading the file. That is, it is someone who does not have the complete file. So leecher is a peer in the network that has only some part of the file, or it has no part of the file. So a leecher is somebody who is still downloading the file. He does not have all the chunks, all the pieces of the file. Then we have a seeder. That is, seeder is a peer that has the complete file, and it chooses to stay in the system to allow. Actually, this is a repetition only. So peer has the complete file and it chooses to stay in the system to allow other peers to download the file. Then we have a peer, that is somebody who uses the BitTorrent and installs the BitTorrent software or some other plugins for web browsers. So anybody who is part of the BitTorrent network is a peer. If you are actively downloading information, you are a leecher. If you are uploading information or you have the complete information, you are a seeder. Then we have studied that a file is divided into pieces. And then each file is further subdivided into pieces. So a file is divided into several pieces, and each of these pieces is further divided into subpieces. So a piece is made up of 16 subpieces. So whenever you are requesting from a peer a chunk of some file, so that request is made at a subpiece level. You are not requesting a piece of the file. You will always be requesting the subpiece of the file. So request between peers for some kind of file in a BitTorrent network happens at a subpiece level. And just to ensure that we are able to download any subpiece faster or any file faster, you can request up to 5 subpieces from any seeder. So what we're saying here is that a file is divided into pieces, and the pieces are divided into subpieces, and each piece has 16 subpieces. And whenever you are requesting some data, some file from a peer, you are always requesting for subpieces. And to ensure that you are able to download those files faster, you can request up to 5 subpieces at any given time. Another thing to note here is that a peer can upload only if it has received the complete file. That is, you can share that chunk with other peers, but you cannot say that, okay, I am a seeder and I will create a .torrent file and upload that .torrent file to the web server. No, you cannot do that. Partial piece cannot be uploaded. So we have seen fetch, we have seen join and search. Now, we have seen search, we have seen publish, we have seen join. Now we'll see how fetch happens. Fetching is downloading anything on the network. Now, the entire focus of BitTorrent is on fetching, because we are going to spend a lot of time in downloading the data. So as mentioned previously, as part of join, the leecher will get a list of peers who are downloading the same file. That is, the leecher contacts the tracker, and tracker will provide him with a list of peers who are downloading the same file. So the question here is that we have a list, we can download that file. So why is fetching such a difficult task? But fetching is a very difficult task on a peer-to-peer, sorry, a BitTorrent network. So in order to facilitate fetch, there are two things that we need to know. So first is, how do you decide which subpiece would you request? Now we know that file is divided into pieces and pieces are divided into subpieces. So how will you determine which piece or subpiece should you request? So we have a piece selection algorithm for that. Second thing is, so okay, once you decide that, okay, I'm gonna ask for this piece, and then the question is, from whom should you request for the piece? The tracker provides you with a list of peers and you have to decide that from whom you are going to request for the piece. And if you are a peer, you will also receive request for pieces and subpieces. So we have a piece selection algorithm to decide which piece or subpiece peers should request. And then we also need to decide whom should you request for the piece. And since you are also a peer on the network, it may happen that you also receive requests for pieces and subpieces. So here you will have to decide whose request you would accept and whose you would deny. So this aspect of deciding whose request you will accept and whose request you will deny is taken care of by choking algorithm. So there are two important algorithms we'll study here. First is the piece selection algorithm, that is deciding which piece you should request or which subpiece you should request. Then second is, since you are also a peer on the network and you will also receive requests for pieces and subpieces, you will have to decide which request you would accept and which request you would deny. So this aspect of accepting or denying request is taken care of by the choking algorithm. So we will see both of these algorithms in detail. So this is like the brief overview of the BitTorrent network. I think we'll stop here for now. If anybody has any questions, they can ask. Else you can drop in your enrollment numbers in the ILCall messages and we'll end the class. Also, there is one important announcement. You have your quiz on Saturday from 1:40 to 1:45, 1:55, sorry, during the class hour. And the topics that are covered are the complete distributed systems, and we will be covering Napster, Kazaa, and GNutella in the quiz.
Ma'am, when is the quiz?
When the quiz is on Saturday, 28th, from 1:40 to 1:55. There will be 15 questions and you will get 15 minutes to answer the questions. Yes, I will share the recordings today positively.
Ma'am, can you repeat the portion again, please?
Sorry, repeat what?
Can you repeat the portion, ma'am? What lectures will be in the quiz?
Okay, okay. So we'll be covering the complete distributed system and the three peer-to-peer networks that we have studied, which is Katza, GNutella, and Napster. And I've also shared the blockchain slides with you all. Just go through those slides. It will be very basic blockchain, like what a blockchain is, or like very, very basic with respect to blockchain, questions with respect to blockchain. So it is mostly distributed computing and peer-to-peer networks, the three peer-to-peer networks that we have studied.
Got it, ma'am. Thank you.
Okay. I will also send an email regarding the same so that there is no confusion regarding the syllabus or the lectures that are being covered. So there is a question, how does a peer know that it is not downloading a redundant piece? So as mentioned that when you create a torrent file, you specify in the metadata the number of pieces you are going to create. And for each of those pieces, there will be a hash that would be calculated and a checksum that would be calculated. So hash is unique to any data, any chunk of data. So every chunk that will be downloaded will have a very unique hash. So in this manner, when the data is assembled at the peer who is the leecher who is downloading the data, the BitTorrent software assembles that data, and when the data is being assembled, checksum operations are performed to ensure that proper data file is assembled. So there is no redundancy. Even if there is redundancy, it is identified and removed, because you will have unique pieces, because SHA1 algorithm will give you unique piece numbers. So this is how it happens.